this video, I'm going to discuss about a couple of spectral problems using the combined data of IR, proton NMR, and carbon-13. So this question is asked in CSIR 2019 examination. The structure of the compound, which displays the following spectral data. So the IR values are given at 1690, 1100 centimeter inverse. The proton NMR, we have one at 2.8 singlet integrating for 3 hydrogens, 3.8 singlet for 3 hydrogens, and we have 2 doublets, one at 6.9 and the second one at 7.8, and the carbon-13 NMR values are given. So let's go to the IR values. We have a peak at 1690 and 1100 centimeter inverse. So a peak at 1690 indicates the carbonyl, but it belongs to a conjugated ketone. That is, conjugation decreases the frequency by around 25 to 30 centimeter inverse. So from this data of 1100 centimeter inverse, that corresponds to an ether linkage. So from the IR data, we can eliminate the esters over here. That is, one can be ruled out, which is an ester, and 2 also can be ruled out, which is an ester. And from the proton NMR, we have a peak at delta 2.8, which integrates for 3 hydrogens, and a peak at 3.8, which integrates for 3 hydrogens. So both structure 3 has got an OMe, which will appear at 3.8, and structure 4 also has an OMe peak, which will appear at 3.8. But how to differentiate these 3 and 4? So 3 and 4 can be differentiated by the appearance of 2 doublets, that is 6.9 and 7.9, which indicates a para substitution. So the doublet pattern will indicate the para substitution. So of the 3 and 4, 3 is the correct answer and 4 can be ruled out. Let's go to the next question. This question is asked in GATE 2013. So an organic compound Q exhibited the following data. So the IR value at 1760% centimeter inverse, and the proton NMR, a peak at 7.2 in 1 hydrogen, and a doublet with a J value of 16 Hertz, and a peak at 5.1, 1 hydrogen multiplet, and 2.1, 3 hydrogens and singlet, and 1.8 for 3 hydrogens and a doublet, and the J is 7 Hertz. And the carbon-13 NMR shows a peak at 170, which indicates a carbonyl carbon. So let's go to the IR data, which will tell us about the functional group. So the IR value of 1760 centimeter inverse indicates an ester. So this is an ester functional group. So of the alternatives A, B, C, and D, C is a ketone. So this can be ruled out based on the IR value. And we have A, B, and D. Let's look into the proton NMR. And let us label the hydrogens over here. In the case of A, we have 2 hydrogens, which is trans alkene. And we have 2 hydrogens over here, which are cis. And we also have 2 hydrogens in D, which are trans. If you look at the NMR data, so we have 2 hydrogens at 2.1, 3 hydrogens, sorry, 2.1. We have 3 hydrogens, which is a singlet. And we have a peak at 1.8 for 3 hydrogens. So in A, B, and D, we have methyl attached to a carbonyl in A and B. And in D, we have a OMe peak. So the OMe will appear at around 3.8. And the methyl attached to a carbonyl, generally we get around 2.2 to 2.4 delta. So from the NMR values, we can eliminate D over here. And the leftover options are A and B. Both A and B, the protons at 7.2, we have 1 hydrogen which appears as a doublet, but the J value, the coupling constant, is 16 Hertz. So these A and B can be differentiated based on the coupling constant. So usually the trans coupling constant will be higher than the cis. So a coupling constant or J value of 16 Hertz suggests that A is the correct option.